The world's fastest scramjet, tailless fighters, reusable drones, and aircraft controlled by artificial intelligence all belong to one extraordinary family. This is the story of America's experimental X-planes from X-41 to X-76. First is the X-41 Common Aero Vehicle, an experimental hypersonic glide vehicle developed under the DARPA and US Air Force Falcon program. Instead of using engines during flight, it was designed to glide through the atmosphere after a suborbital launch at speeds exceeding Mach 7. The aircraft was intended to deliver payloads more than 9,000 nautical miles in under 2 hours, although no operational prototype was ever publicly confirmed. Next is the X-42, a proposed reusable launch vehicle developed by Orbital Sciences Corporation. Rather than serving as a conventional aircraft, it was designed to carry the X-41 Common Aero Vehicle into space using a single RS-27 rocket engine before releasing it for hypersonic flight. The concept promised a reusable and lower-cost launch system, but remained a paper design and was never constructed. Now this is the X-43 HyperX, NASA's revolutionary hypersonic research aircraft. 3 X-43A HyperX vehicles were built, with the final flight reaching a record-breaking Mach 9.6, making it the fastest air-breathing aircraft ever flown. Planned X-43B HyperX and X-43C HyperX variants were intended to introduce reusable combined-cycle propulsion and hydrocarbon-fueled scramjet technology, but both projects were cancelled before construction, leaving the X-43A as the program's only flying version. The X-44 multi-axis no-tail aircraft, better known as Manta, was a Lockheed Martin concept based on the F-22 Raptor. It eliminated both vertical and horizontal tail surfaces by relying entirely on three-dimensional thrust vectoring for control, improving stealth while maintaining high maneuverability. Although the full-scale concept never progressed beyond design studies, a separate X-44A tailless technology demonstrator reportedly flew to evaluate advanced tailless flight characteristics. Following it was the X, Unmanned Combat Air Vehicle, Boeing's ambitious stealth drone program. The X-45A successfully demonstrated autonomous flight, precision weapon delivery, and coordinated control between multiple unmanned aircraft. The larger X-45B was cancelled before completion, while the improved X-45C introduced greater range and payload capacity before evolving into Boeing's Phantom Ray demonstrator. A naval version, the X-45N, was also proposed for aircraft carrier operations, but was never built. Next is the X-46 Unmanned Combat Air Vehicle Navy, or X-46 UCAV-N, Boeing's proposed carrier-based stealth combat drone. Developed alongside the X-45, it was designed specifically for aircraft carrier operations with autonomous takeoffs, landings, and strike missions. However, when the Air Force and Navy merged their unmanned combat aircraft efforts into the joint UCAS program in 2003, the X-46 was cancelled before any prototype was built. Now this is the X-47 Pegasus, Northrop Grumman's groundbreaking carrier-based unmanned aircraft. The X-47A Pegasus served as an early technology demonstrator, proving autonomous flight and carrier approach capabilities. It was followed by the much larger X-47B Pegasus, which became the first unmanned aircraft to launch from and land on an aircraft carrier before completing the world's first autonomous aerial refueling. Although it never entered production, it transformed future naval drone development. The X-48 blended wing body explored a radically different aircraft shape by merging the wings and fuselage into one lifting surface. The planned X-48A was never built, but the X-48B successfully completed more than 80 research flights to evaluate aerodynamic efficiency. Engineers later developed the quieter X-48C, which used 2 engines instead of 3 to reduce noise, while continuing research into future transport aircraft. Following it is the X-49A Speedhawk, an experimental compound helicopter developed by Piasecki Aircraft. Converted from a Sikorsky YSH-60F Seahawk, it replaced the conventional tail rotor with a vectored thrust-ducted propeller while adding small wings for extra lift. These modifications increased its maximum speed beyond 200 miles per hour, demonstrating how conventional helicopters could achieve much higher performance without sacrificing vertical takeoff capability. Next comes the X-50 Dragonfly, a Boeing experimental aircraft built around the innovative canard rotor wing concept. It was designed to take off vertically like a helicopter before stopping its rotor in flight and using it as a fixed wing for high-speed forward flight. 2 prototypes were built, but neither successfully completed the transition, leading DARPA to cancel the program after several unsuccessful tests. Now this is the X-51A Waverider, one of America's most successful hypersonic research aircraft. Powered by a hydrocarbon-fueled scramjet after being boosted from a B-52, it reached speeds above Mach 5 while sustaining powered hypersonic flight for more than 3 minutes. The program built directly on lessons learned from the X-43 and became the technological foundation for several modern U.S. hypersonic weapon programs. The X-53 Active Aeroelastic Wing was a modified McDonnell Douglas FA-18A Hornet developed to test advanced wing control technology. Rather than resisting wing flexibility, engineers deliberately used aerodynamic forces to twist the wings for roll control. The successful program demonstrated that lighter, more flexible wings could improve maneuverability while reducing structural weight for future military aircraft. Next is the X-54 Gulfstream Low-Boom Demonstrator, a proposed NASA and Gulfstream research aircraft designed to dramatically reduce the sonic boom produced during supersonic flight. Building upon earlier quiet spike experiments, it aimed to make oval and supersonic travel practical. However, funding limitations and regulatory challenges prevented construction, and the concept was eventually superseded by the X-59 Quare SSD. The X-55A Advanced Composite Cargo Aircraft, also known as the Advanced Composite Cargo Aircraft, was converted from a Fairchild Dornier 328 jet. Instead of testing speed or maneuverability, it focused on revolutionary composite manufacturing techniques. Engineers successfully demonstrated that a large composite fuselage could be built using far fewer parts than conventional metal structures, significantly reducing production costs and assembly time. Following it is the X-56 Multi-Utility Technology Testbed, often called the X-56 MUT. Developed by Lockheed Martin, it was designed to study active flutter suppression using extremely flexible high-aspect ratio wings. Although one aircraft was damaged during testing, the second continued NASA's research into lightweight wings that could improve the efficiency of future high-altitude and long-endurance aircraft. Next comes the X-57 Maxwell, NASA's first all-electric X-plane and its first piloted X-plane project in more than 2 decades. Based on a modified Technam P2006T, the final design featured 14 electric motors powered by advanced lithium-ion batteries. Although the aircraft never flew because of late-stage propulsion safety issues, the project generated valuable data that continues to influence electric aircraft development. Like the X-52, the X-58 designation was never assigned to an official X-plane. The number was effectively bypassed after the XQ-58A Valkyrie received the 58 designation within the unmanned aircraft series, leaving X-58 permanently unused in the experimental aircraft sequence. Now this is the X-59 Quiet Supersonic Technology, better known as Quare SSD. Developed by NASA and Lockheed Martin Skunk Works, it is designed to replace the traditional sonic boom with a much quieter sonic thump through its extremely long and slender airframe. After completing its first flight in 2025, the aircraft achieved its first supersonic flight in 2026 and continues testing for future civil supersonic travel. The X-60A Generation Orbit Hypersonic Test Vehicle was designed as an air-launched liquid-fueled rocket for hypersonic research. Released from a carrier aircraft, it was intended to test scramjets, advanced materials, and autonomous flight systems at speeds between Mach 5 and Mach 8. Despite extensive ground testing, the program never completed a powered flight before quietly coming to an end. Next is the X-61 Gremlins Air Vehicle, developed by Dynetics under DARPA's Gremlins program. Designed for rapid reuse, the drone could be launched from a C-130 transport aircraft before being recovered in midair by the same aircraft. The concept aimed to provide low-cost swarming drones capable of intelligence, surveillance, electronic warfare, and other missions with minimal turnaround time. The X-62A Variable In-Flight Simulator Test Aircraft, commonly known as VISTA, is a heavily modified F-16D used for artificial intelligence flight research. Under DARPA's Air Combat Evolution program, it became the first aircraft to conduct air-controlled within visual range dogfights against a human pilot. The aircraft continues supporting autonomous combat research and has directly influenced the U.S. Air Force's next generation of AI flight programs. The X-63A Aerospace Demonstrator was assigned under the Air Force Research Laboratories, a RISE program to evaluate advanced aerospace rocket technology. Developed around ABL Space Systems' launch vehicle, the project experienced repeated setbacks after launch failures and hardware losses. Following major company restructuring, the program's future remains uncertain with no confirmed flight activity. Following it is the X-64A Aerospace Demonstrator, the parallel entry within the same RISE program led by Invoken. Like the X-63A, it was intended to advance aerospace propulsion research for future launch systems. Only limited public information has been released, and the project appears to have stalled without any confirmed flight testing. Next comes the X-65 Control of Revolutionary Aircraft with Novel Effectors, or CRANE, developed by Aurora Flight Sciences for DARPA. Instead of conventional ailerons and rudders, the aircraft uses precisely controlled jets of compressed air to maneuver. This active flow control system could eliminate many moving control surfaces, simplifying aircraft design while improving aerodynamic efficiency and reducing maintenance requirements. The X-66 Sustainable Flight Demonstrator is based on a heavily modified McDonnell Douglas MD-90 and forms part of NASA's Sustainable Flight Initiative. Its enormous transonic truss-braced wings are designed to improve fuel efficiency by approximately 30% compared with today's single-aisle airliners. Although development was paused in 2025, the research continues to support future environmentally efficient commercial aircraft. Now this is the X-68A Longshot, General Atomics' innovative unmanned missile carrier developed for DARPA. Instead of engaging enemy aircraft directly, it is designed to launch from a crewed fighter, fly ahead of the formation, and fire its own air-to-air missiles. By extending engagement range while keeping pilots farther from danger, the Longshot introduces an entirely new approach to aerial combat. Finally, we have the X-76 Bell SPRINT Demonstrator, developed under DARPA's Speed and Runway Independent Technologies program. This experimental aircraft combines vertical takeoff capability with high-speed airplane performance by folding its rotors after takeoff and transitioning into wing-borne flight. With cruise speeds expected to exceed 400 knots, the X-76 aims to bridge the gap between helicopters and conventional fixed-wing aircraft.